Welcome back, Algebra 2 students. Today we are going to begin section 5.5, which is on function operations. So if you're using the packet that you got from school, that's not the packet. There it is. You are beginning on page 17 of that packet, the handwritten page 17. I also posted a packet if you want to get all of the try it problems. I posted a packet online on our website in the column where I post all of the worksheets and the answer keys. So if you want to pause the video and download those worksheets, you'll have all the try its along with the examples. Okay, so let's get started. So function notation, that's a very important notation, right? F of x, g of x. We've looked at this before. The importance of it is it makes our lives a little easier because we're giving the function a name. Right? So instead of having to say 3x plus 4, I can just refer to this as the function f of x. So f is its name, x is the variable that's being used in the function. So do not confuse this with multiplication. This does not mean sum f times an x. That's not what the parentheses mean. This is read as f of x, and it's, again, the name of the function is f, and the x tells you the variable that's used. So it could have well been named p of n. Then the name of the function would be p, and an n would be used, so it would be 3n plus 4. So here we have g of x. G is the name of the function, and again, x is the variable used within the function. So I can refer to this whole thing as g of x, so I don't have to say every single term. It also helps us with how to write things out. It helps us with other notation. For instance, if I want to write the sum of f and g, I can write that in two ways. I can write f plus g of x, which is the same as saying f of x plus g of x. So in this section, you will be writing out the notations, and then you'll actually be calculating what is f plus g of x. And you already know how to do that part of it. F plus g of x means take the f function, 3x plus 4, and add it to the g function, which is x squared minus 5x plus 2. You learned this in Algebra 1. This is just adding like terms, right? So this is 3x minus 5x. Oops, start with the leading term, x squared. There's nothing to add to that, so it stays the same. Then 3x minus 5x is minus 2x, and 4 plus 2 gives us 6. So there's our new function named f plus g of x. Okay, what is the difference of those two functions? So for the difference, we would write that as f minus g of x, which is the same as f of x minus g of x. So now I'm taking 3x plus 4, and I'm subtracting g of x. Now when I do that, I'm going to put a parenthesis. When we're adding, we didn't need it, but when we're subtracting every term. So we need to remember to distribute that negative and change the sign of all three terms. So I'll bring down the 3x plus 4. Then it's minus x squared. It'll become plus 5x and minus 2. So the parentheses are a good idea just to remind yourself to distribute over all three terms. Now we combine the terms. So we have negative x squared. 3x plus 5x is 8x, and 4 minus 2 gives us 2. So here's our f minus g of x. Okay, so that would be the name of this function. Okay, let's do some try-its. So if you have your student companion, you can do these right in your student companion. Or you can just copy them down onto the notes if you have the notes from school, or if you have the new set that I posted on our website, you can continue on to this page. Pause the video, take these two functions, write out the notation, f plus g of x, which is the same as f of x plus g of x, and then add the two functions together. Here you're doing f minus g of x, which is f of x minus g of x. And remember with this one to distribute that negative over both terms of g of x. So pause the video, go ahead and try those two, calculate, get the new functions, and then come back and we'll compare solutions. Okay, so hopefully for the sum, after combining like terms, you got 2x squared plus 5x plus 2. And for the difference, 2x squared plus 9x minus 4. Let's go on to example 2, where we're talking about the demand and the price of a certain item, in this case cell phones. So the demand in units sold for a company's new brand of cell phone at a price X in dollars is this function, which we're calling d of x. That's our demand function. What is the company's expected revenue from cell phone sales in terms of the price, which is x? So here's our equation. We have the revenue, which we'll call r of x, is equal to the price, which we'll call p of x, times the demand, which is d of x. So we're going to come up with a function for revenue that's based upon the product of price times demand. And that'll give us a new function, which will be the revenue function. So r of x is equal to, we're going to take that p of x function, which is just x, and we're going to multiply it by the demand function, which is 5,000 minus 10x. So all we have to do is distribute the x, so we have 5,000x minus 10x squared. So that's our revenue function, r of x. Okay, so that would give us the revenue based upon the price being x. Okay, let's go to the try it. So you're given again the demand function, okay, the price function, p of x, and you're asked to calculate the revenue. So again, revenue, which we'll call r of x, is d of x times p of x, which can also be written this way. Sometimes you see a little dot, sometimes you might not. So go ahead and plug those functions in. They're both binomials, so you're going to have to FOIL, distribute, and get your terms. So pause the video, give it a try, come back, and we'll compare solutions. Okay, so hopefully you got this function here. This is our revenue function, r of x. So when you're distributing, let me start with the d function. So d of x is negative 0.25 x squared plus 1,000. And you're multiplying that by x plus 16. So when you FOIL this, negative 0.25 x squared times x gives you the negative 0.25 x cubed. Then the outers, negative 1/4 of 16 is negative 4. So we get the negative 4x squared. The inners is 1,000 times x. And the last two terms is 1,000 times 16. And there's our last two terms. So really this section, none of the mathematics is any different from what you've learned before. It's just a matter of getting used to the new function notation. Okay, our last example for today is about the division of two functions, okay, or the quotient. So how do you define the quotient f over g of x? So we can write that again in two ways. We can write it as f over g of x. I don't like how the book is leaving out the x. There really should be an x there. I've never seen it without, to be honest with you. We can also write that as f of x over g of x. So we're going to take the f function, which is x minus 7, over the g function, 2x squared, minus 13x minus 7. Now, the only thing we can do with the quotient is reduce if we have a common factor. So that means that we would have to have a factor of x minus 7 in this denominator. So what I'm going to do is set this up, see if it works with that x minus 7. If I have a factor of x minus 7, that means that the other factor would have to be a 1, right, a positive 1, to give me that quotient of negative 7 for the constant. So let's see if it works. We get 2x squared from the first terms, that's good. 2x times negative 7 is negative 14, plus a 1x gives us the negative 13x. So this does work. So I'm going to rewrite my function in factored form. This goes back to our section that we did on division of polynomials. Do you remember doing all that factoring and then reducing out the common factors? That's what we're going to do here. But before we reduce out, I know you're going to be asked to also state the domain of this quotient of f over g. So the domain, we want to look at that prior to reducing our factors. Remember that? We always looked at the original function. So the domain is the values, all values except for the ones that give us zeros in the denominator. So the two values that would give us 0 in the denominator would be x not equal to negative 1/2 and positive 7. So using our interval notation, we would go from negative infinity to negative 1/2, and then unioned with negative 1/2 to 7, and then unioned with 7 to infinity. Okay, once you've done that, so there's one part of the answer, which we weren't asked for in this example, but you'll see it in the try it, you'll see it in your homework. So there's the part if you're asked about domain. Now we can finish up by reducing out the common factor that we have here. So remember, this doesn't become a 0. When we reduce out that factor, we're left behind with a 1. So we have 1 over 2x plus 1, and that's our function f over g. So 1 over 2x plus 1 is the f over g function, and here's the domain of f over g. Okay, so let's try the try-its. Go ahead and set these up, and notice it does say and domain. So you're going to find f over g, and you're going to state what the domain is for f over g for both a and b. So pause the video, give it a try, and then when you're done, come back and we'll compare solutions. Okay, so let's see. Hopefully for letter A, you got the function x minus 6, right? Because for this one, you're putting f in the numerator. And again, use this as a hint. If it's going to be factorable, it means that x plus 3 is going to be a factor of f. So if I have x plus 3, that means my other factor would have to be x minus 6, right? To give me that minus 18 for the constant. So if I have that over g, the domain will be x not equal to negative 3, which is stated here. The x minus 3 is reduced out, so this time the 1 is in the denominator, So the function is just x minus 6. For this one, we have x minus 3 over the g function, which is x squared minus x minus 6. So again, if it's going to be reducible, that means x minus 3 would have to be a factor, which means the other one is x plus 2. So I have two values that x cannot equal, positive 3 and negative 2. The x minus 3's reduce out. I'm left with a 1 in the numerator over x plus 2. So that concludes our lesson for this part of the section. We'll continue on next class with part 2 of section 5.5. So your assignment is from worksheet 5.5, the additional practice. You're not doing the entire worksheet, so look on the website in the assignments block for what the actual problems are that you have to do, and then submit it through the assignments block. Okay, so I hope you enjoyed the lesson, and if you have any questions, you can meet me on Zoom, and remember that's any day of the week from 11 to 12 o'clock. Okay, have a good day, guys. I'll see you soon.